Hello, everyone, and welcome to my talk about raising security awareness using cybersecurity challenges in embedded programming courses. My name is Samra Hodzic, and I'm a working student at Siemens and a master's student's degree at Technical University of Munich. Throughout my work, my supervisor was Tiago Gaziva. He's also working at Siemens and pursuing his PhD at the Universität der Bundeswehr. This work was also done along with Professor Ulrike Lechner and Professor Maria Pinto Albuquerque. So so how it's going to look now, we're going to start with the motivation. Then I'm going to introduce the CIFO platform on which this work was based on. Later on, I'm going to introduce the challenges for embedded programming. How do we integrate these challenges in the existing platform, validation of this implementation. And as a last step, what we did was evaluation in academia, since the CIFO platform was mainly developed for software developers in industry. So let's start with the motivation. So as we could notice in the past years that cybersecurity incidents are rising. And for example, from year 2018 to 2019, we could see a 350% increase in cybersecurity incidents. And according to IBM, they say that 95% of all security incidents involve human error. So based on that factor, we were kind of targeting software developers. And so in the previous research and also in this conference, we have seen presentations which are doing research on several tools. And also, like, some of them are working on code review. This presentation, this work has a focus on raising cybersecurity awareness, and that all doing by training software developers on secure coding. So in order to introduce training software developers for secure coding, let's first introduce cybersecurity awareness challenges. So those challenges are so-called serious games, which have kind of learning outcome, so learning goal. They can have like two perspectives, so offensive and defensive perspective. The participant, so the player, is either attacking a system or defending a system. Sometimes these challenges are also kind of combining these two approaches. When it comes to defensive approach, the software developers or the participant is coding a certain task, but in a way that it's not being able to get attacked, or it doesn't have any security bugs. And that's the approach that the CIFO platform that I already mentioned is using. So as I said, CIFO platform is a web application which is integrating these defensive challenges, and is mainly was developed for raising security awareness on software developers in industry. So in order to understand better this presentation, let's have a look how the CIFO platform works and how the participants perceive it. So as I said, it's a web application, and here we can see how it looks from players, participants' perspective. In the middle, we have the project, so the challenge itself. The player is given a certain task, so the player should code, and after submitting a solution, the platform analyzes it and looks if there are any security threats, and or of course unit functional tests if they're passing or failing. After submission, the user is given a feedback at the bottom, and based on that, the player can see if there are some security threats, which are they, if they are, and based on that, the player can code further. On the right side, we have the so-called virtual coach, which is supposed to give kind of hints and engage the player throughout the game, throughout the challenge, so that yeah, we don't lose the focus and the player learns as much as possible. Yeah, so that's how it looks from the front-end side. How it works under the hub. So this is a abstract diagram. So we see here that we're getting the kind of the solution of the participant, and we are injecting some internal files in order to being able to detect security vulnerabilities. This path here is existing in the platform, so through the compilation and running unit tests and all different kind of security tests. And we're gonna talk about this further. At the last stage, we have the artificial engine. So here the platform is analyzing the results, and based on that is giving a feedback or also a hint if it sees that the player needs it. Okay, so now to the work itself. As I said, this work focuses on challenges for embedded programming. So when I say embedded programming, I am meaning that we try to target some challenges which occurred in some programming courses that I had throughout my studies. And basically the two research questions that we have is first, how to decide whether a challenge was correctly solved. And here, what we mean is that, okay, if we are targeting some embedded specific problems, do we need to add here something in the path of this platform? And if yes, what and how can we solve it? And the second question is, how do students perceive the challenges presented through the CFU platform? And this question arises because the platform was mainly designed for software developers in industry, and it's targeting that industry perspective of programming. And so we wanted to see if it can be applicable for training students and in some embedded programming courses. For every, how are we gonna approach this? We are first going to explain the challenge design and implementation in the platform. Then do we need to add a security bug detection mechanism for a certain problem, a validation of that detection mechanism, and at the end, evaluation in academia. Okay, so let's start with the challenges. So 3 challenges were presented in this work. These 3 are kind of common in embedded programming courses, and we think raising awareness on these is a good start towards secure embedded programming. First is memory corruption with an example of complex factory class. So as we can see here in the table, we have the challenges and the rules that are violated. And we can see that we are trying to cover some memory violations in order to make the participant train that skill and raise awareness on that. Second challenge was a time side channel with application on a sorting algorithm. And third challenge was race condition. So time of check, time of use with example, a challenge of file access, which can be common in embedded programming. Okay, so first challenge, so as I said, we have some memory corruption. Let's have a quick look. For example, line 25, we have a violation of this rule, which says do not read uninitialized memory. If we go to the line 25, we can see that we are returning container elements, but we are not checking the index, which can lead to reading a memory that we don't own, or if we do, we didn't control the content in it. Then, for example, line 18, do not access an object outside of its lifetime. We go to line 18 and we can see that in this part of code, we are gonna have a dangling reference, yeah, which can have also some critical, which can add some critical points in our code. In order to detect these, the platform didn't need any additional tool. It was possible with compiler sanitase flags to detect runtime memory issues, and also with security tests and unit tests, we were able to detect, yeah, the rules that we wanted to cover here in this table. And yeah, so having these runtime security tests. So when using this class, the API in a way that user doesn't expect it, we were able to detect these vulnerabilities and guide the player throughout this challenge. The second challenge is time side channel. So let's first quickly mention what is a time side channel. So here in this box, we have a simple password check where we are sending, kind of trying to check if the given password is the correct one, the stored one. And this password check is weak. Why? Because if I have the first 3 characters right, this check is gonna take 3 units, 3 time units, some. And if I have, for example, first 5 characters right, this check is gonna take 5 time units. And based on that, we could be able to get the correct password just on this time side channel. So this time side channel can be yeah, can find application in many different methods. But the question that arises yeah, by us is how can the platform check this vulnerability, since we don't own an embedded device and the platform is using a shared CPU and using the integrated yeah, timing at the CPU, so we weren't able to detect what is exactly the execution time of this code. Therefore, we had to come up with our own solution for the platform. We came up with using GDB debugger and using instructions to GDB instructions to count the number of instructions of the player's code. So if we see that, yes, if the number of instructions changes when we give different inputs, then we could see that there's a time side channel. So how we did it was, okay, using GDB commands. And the main question was, okay, when we are counting instructions, how deep should we look into it? So it was either should we use step I, so step instructions, or just step. And yeah, we should validate what is the delay from the platform and how good is it able to detect a time side channel. We are going to see the validation further. And third challenge was race condition, so time of check, time of use. Usually it can be described and as if we have a file access and there's a gap between accessing and using or opening the file. And that gap is called race window, where an attacking program can use that to control a file that it usually doesn't have an access. To check this, we had a thought to trap system calls, but that wouldn't be safe since the platform would automatically be kind of vulnerable. Therefore, we tried to attack the player's code, actually attack, and in order to win this race, what is the number of attacks that we need to proceed in order to have a probability for the platform that it's acceptable. Okay, let's look at now at the results of the validation. So for the time side channel challenge, we can see here the first graph. On the left side, we have the step I instructions. On the right side, we have the step instruction. We have with time side channel and without time side channel. This diagram shows that both methods are able to identify a time side channel, since we see that without time side channel, we don't have any difference in execution, and with we have. The difference between these two methods is that the step I takes way more time, so it takes around so it takes approximately 10 seconds, and the step takes around 1 second. And based on that, we decided to proceed with step instruction because the delay from the platform shouldn't exceed a certain limit, so that the player doesn't lose attention and is still focused on the challenge itself. For the race condition, on the left side, we see the probability, and here we have the number of tries. We can see, so tries to attack the system in order to have this certain probability. We can see that around 2000 tries, we are gonna have almost 90% chance to successfully detect if there's a race condition, and around 10,000 we were close to 99% to detect race condition, which is acceptable for the platform, although it's not working 100% correctly, and yeah, some improvements should be done. Now to the evaluation in academia. So as said, the CIFA platform is designed for software developers in the industry, and we wanted to see how it applies for students in academia. So 2 test runs were conducted. In total, 16 students responded to this event. And yeah, so here we can see the survey questions, which have just this kind of abstract view over the platform and how does the student perceive these challenges. To the results, we can see that the results are mainly positive, so that they have learned new techniques and principles of secure software development and so on. What we could see is that the question 2, university teaching includes awareness in secure coding, that they mostly disagree, and that I think that should be kind of an indicator to pay more focus on raising secure coding awareness. So back in academia, so for students, so that they are already prepared for the industry. So the results are positive, and they indicate that the platform could be used for in embedded programming courses. Yeah, so similar studies were conducted previously, and yeah, these challenges are kind of, we try to align them with previous studies in order to compare how the academia compares to the industry, not exactly compare, but is the platform also applicable for academia? The results are mainly identical, so in terms of percentage, except for question 5 and 7. So let's analyze quickly these two. So question 5 is, I understand the importance of secure coding guidelines. And in industry, we couldn't see any disagreement, while in academia we could. And probably the reason for that is that students are not aware of the secure coding guidelines, which are important in the industry, and they are not able to understand, like just through one training, to understand the importance. So again, that's also on secure teaching in academia. And question 7, I have learned about new issues that I would like to check on in my own code. We didn't see any disagreement in academia, so that the students weren't aware of these vulnerabilities and threats when we compare to the industry where some software developers already experienced and it wasn't applicable for them. In the summary, so 3 different C++ challenges were implemented on CFU platform, targeting embedded programming exercises, and we try to explain the security bug detection methodology and to show the validation. Of course, the validation that we have shown is just a part of it. The challenges uses the CFU's platform validation, including unit tests. Also, as I said, compiler sanitase flags for runtime memory issues, and so on. The preliminary results have indicated that the CFU platform can be used in academia, and that the challenges are adequate to raise secure coding awareness for students as well. And at the end, we saw that the results are in alignment with studies in the industry. For further steps, we would like to improve the security bug detection and hint mechanism to help solve the bugs. And by that, we're trying to introduce new tools in order to be able to cover as much as possible security bugs which can occur by solving challenges which maybe don't have focus to solve these. Yeah, so that's all from my side today, and yeah, thank you for your attention.
Thank you very much. That was
You're
interesting.
welcome.
Again, forgive me for stupid questions. I will definitely ask them. So as far as I understand, you are asking students to look at the code and respond back whether they see the problem there or not. Am I right?
Actually, they are trying to code. So they are given a task. So let's say implement string compare, and maybe they have some part of the code or they don't. So they are coding that specific functionality, and we are checking if there are security vulnerabilities. So it's more coding challenge.
And then maybe I missed the percentage, like how many of them were making mistakes and how many of them were not making mistakes. What was their
yeah, so
I remember you had 60 students, but I didn't maybe I missed the number.
Yeah,
like
so
how
if we see here, we don't actually look of do they make mistakes or not. We could see that they learned like new secure coding guidelines or new principles to secure software development, and also that the question too that they agree that they disagree that university teaching includes awareness in secure coding, which I also kind of agree with that since I'm still a student.
So you were telling them back whether it's okay or not okay, and they are just learning from that, and then they ask them from the surveys, like, what did they learn? Okay, I understand.
Yeah, so the platform is actually giving the feedback. So
okay. Yeah. And you selected these 3 specific mistakes people make, like 3 security bugs. And how many more do you think it's possible in general to put into the system? Now you have 3, but maybe how many is left? I mean, potentially.
Yeah, so the platform is in research since 2018, and so far it has around 20 challenges for C and C++. These 3 are mainly for embedded programming, so nothing specific to embedded programming, but they usually occur in embedded programming courses as kind of some important fact. And I think if we focus more on what could go wrong and what are the usually attacks on embedded systems, we could always come up with challenges to improve that and to reduce the number of attacks on these vulnerabilities.
And when you find the bug, do you give some explanation to the student about why it's a bug, some maybe references to some literatures, or you just say there's a bug in line number 17 and that's it?
Yeah, so the platform, every challenge is kind of has this starting focus, so on certain vulnerability, but of course underneath we have a database of tests and hints to other security vulnerabilities. And yeah, when a participant makes a mistake, sometimes we directly say, okay, it's this vulnerability, please have a look there. But sometimes we just give a kind of abstract hint so that we don't make it too easy, because of course some of us have already something in mind, so and we just need a little push, and we wouldn't like to get the answer immediately. And yeah, if the platform sees that the player is struggling to solve it, after maybe 2-3 submissions, it's gonna give a correct hint and help solve the challenge easily. So hope that
Hi, Yeko. I hope you can hear me.
yeah.
Awesome presentation, Samra. Thanks for taking over. Maybe I can add a little bit to this, which is the following. So there is actually an artificial engine based on the so-called laddering technique, which is so when we find some vulnerabilities in the code, we start giving more and more detailed hints to the participant. Until the last level would be, okay, this is the problem, and this is how you have to fix it. And this is possible because we control the code and we control the situation very closely.
And how many in total students went through this? Because I know in the surveys you have 60, but how many over this few years, how many students went through the system?
So
for the industry, there were about 200 people that have experienced the platform. So this was integrated in design science efforts on the PhD that I'm going to finalize in soon. And we decided, in this case, we decided to take the approach that was taken at the industry, and we decided to evaluate it in the academia. So that's why we had 16 people in this case.
That's big numbers for education. 200 people, that's a lot. And who is who is writing these challenges? Who is writing this inside? You doing it yourself, or how is it organized?
We are doing it ourselves, so I did this during my PhD research, and this is being driven by internal projects in the company. As you see, so we also have some external students. There is currently 3 working at the time, developing challenges and being directed towards this. So the platform is also being expanded. So in last week, for example, we had our first Java challenges. So we integrate, these are for C++, and now we also have Java challenges. And then in the next iteration that we'll also like to publish this in the future, we are going to do infrastructure as code. So we are going to do Terraform challenges.
And do you think this approach can be used to other educational purposes, not only for security bugs, but maybe for just learning, teaching people how to write better Java code? Like give them the challenge, write this algorithm, and they write, and there's a static analysis, which is watching what's going on there and giving the feedback in like immediately.
Yes, awesome. Very good question. So one of the things that that is currently being thought about is train people to use static analysis tools, because the quality of those tools is known not to be the best one. And we've seen already some examples in the conference. So to be able to train developers to distinguish false positives, that would be an interesting look that we could take. So we don't know the outcome of this research, but it could be one area that we could do additional research. Yes.
Because I'm trying to understand the core innovative part of your project is actually the combining the students on, or like people on one side and then AI on another side, and immediately giving feedback of the code people write, and then putting this whole thing in the loop. And that's your innovative idea. And then this loop actually improves the quality of people. I mean, their skills, right?
Yes, yes.
So it doesn't really matter what you put in the loop, as long as you have the person on one side and then you have some machine which is giving the feedback and kind of trains people in this way, right?
Yes, that is absolutely correct.
So you pick security problem, and that's great. So maybe I'm just thinking maybe there could be other potentially other machines doing some other checks.
There is also some other ideas that we are thinking about following, but we didn't. The thing is that this is mainly driven by the industry, and the use case has been security. But another one might be simply coding style, coding guidelines in terms of style, so that you can use the platform to train developers to say, okay, the style that you are using is not the one that is supposed to be used in this project. So this is an example of additional things. Mm-hmm.
Right.
Conventions, naming, whatever. So the idea is really it can be. I think it's almost not. There is no limitation on the imagination on how this could be used.
Okay, it sounds interesting. The time is over. Many thanks, Samra, for your presentation, for taking over, like Thiago said.
You're welcome.
Yeah, and thanks for submitting to our conference. We hope to see you next year. That's it. I'm turning off your microphones. Bye-bye.
Okay, thanks a lot. Take care. Bye-bye.